In our next section, we're going to look at how we can use LISP to do Ingress load balancing based on a ratio that we set. And after we have our basic initial config set up to this point, you'll see that using or modifying the load balancing is a very trivial change to LISP. It's just going to be based on the Ingress and egress tunnel routers when we go to register the endpoint identifiers to the routing locators, that we specify multiple routing locators, and then what is the weighting going to be between them. So if we take a look back at our current design, what we have here is two egress and ingress tunnel routers, which are router 5 as the XTR and router 3. We had router 8 up at the top as the map server and map resolver, where router 5 is then telling router 8 that if you want to get to this endpoint ID, which was 6666/32, you should use the routing locator that was this interface 10.1.5.5, or that IP address more specifically, that's used to connect towards router 1. And then when router 7 sent packets in to router 3 does a normal unicast routing lookup. It says, I don't have a route to this destination. That's going to trigger me to ask the map resolver, do you have a route to this particular destination, or do you have a mapping to that destination? So then router 3 asks 8. 8 says to 3, yes, I know about it. 5 is the one who has that resolution. 3 then sends the request over to 5, or actually it's technically the other direction, that 8 forwards it to 5. Then 5 says to 3, here's what the resolution actually is. And then bidirectionally we have the transport between the two of them. Now the next case would be then, well, what if we have multiple ways to get to the route? So let's say that we have, from router 3's point of view, 2 different ways to reach the core. We can go through routing locator A, or we can go through routing locator B. It means that router 3 is going to have to register both of those to the map server. And then when router 5 asks the map resolver, it's going to reply with both of the routing locators, and then we should be able to do a load distribution between the two of them. So if we take a look at our configuration on router 3, what we've done up to this point is to say that we have two different endpoint IDs. So we have the loopback of router 7, and then we have that physical link that's connecting to router 7. And we're mapping these to our egress interface. This is basically our tunnel endpoint. So when we looked at this from a data plane point of view, and we went to our Wireshark capture, and let's look at those pings, notice that the destination of the IP packet is that interface on router 3, which is what we had specified here as the routing locator. So it's basically your tunnel source and your tunnel destination you're specifying when you do this mapping between the two of them. Okay, so now let's say that we have more routes that we want to map. So we could either do more database mappings like we have here, specify what are the endpoint IDs, and then specify where they're mapping to the routing locators. Or there's kind of a shortcut way that we can do this by also adding in what is a locator set. Okay, so on router 3, under router LISP, we're going to say that we have a locator set. Okay, the locator set is going to be, we'll say that this is R3 set, okay, with any arbitrary name. And what are the addresses that we're mapping to? Okay, the addresses, if we look at the do show IP route connected, or actually let's say show IP interface brief, they are going to be 10.3, 13.3, and 10.2.3.3. So our egress interfaces. We'll say 10.2.3.3 is going to have a priority of, we'll say 100, and a weighting of 50. Then likewise, we have 10.3, 13.3, and same values. So this should mean that when we do a load balancing between them, we're going to do it on a one-to-one basis based on the flow information of the traffic going between the servers or whatever the applications are. Okay, we then take our locator set, and we're going to tie this to our database mapping. So if we look at the show runs section LISP, we're going to remove these two database mappings here. Then we're going to recreate them But the difference is that instead of pointing them directly at the IP addresses, we're going to point them at the locator set. So it's just a shortcut in the syntax. There's no functional difference between them. Just the idea is that if you have additional addresses that you want to advertise as your egress interfaces, you just add them to the locator set or remove them from the locator set, and then they automatically get updated for all of the endpoint IDs. Okay, so same thing should be true for this second one. It's going to go to that locator set, which is router 3 set. Okay, if we now look at this from the map server's point of view, which is router 8, and we look at the show LISP site, we can see that the address is registered, okay, 7777 and 10370. And if we look at the site detail, show LISP site detail, and we're specifically looking for the, or let's say site for the EID, 7777/32. It says what are the different locators that it has available. So you can reach it via the link from 2 to 3 or the link from XR3 to router 3. If we go on the other side, which is router 5, the one that's actually going to tunnel towards this, and if we now look at the show IP LISP map cache, we should see that when we go to do a new resolution, so we ask the map resolver, how do we get to 7777? It's going to reply back and says you have 2 ways to get there. You can go through XR3 or you can go through router 2. Now, eventually, this mapping is going to expire and then it's going to update it. But in our case, since I want to just forcibly do this, we're going to say just to clear the IP LISP map cache, and we'll just clear out all of the entries. Okay, this is going to go back to the default, which is none. Okay, so next, let's go from router 6, and we're going to do a ping over to 7. So we'll ping 7777. Source is 6666. We should see again, first couple packets are lost because we're in the process of doing the resolution. And then eventually, once the resolution comes through, we can see that we have reachability. Now from router 5, when we look at the show IP LISP map cache, we now see that there's 2 locators. Now again, these specific values, what they mean is that the routing locator with the lowest priority is going to be the one that is used. If the priorities are equal between multiple locators, then we're going to load balance the traffic. So if we were to say that this top one was 100 and the bottom one was 50, even though the weights are equal, it means that only this one would be used and this one is excluded. But in this case, since both of the priorities are equal, then we're load balancing on a ratio of 50 to 50, or in other words, 1 to 1. Okay, now the way that we can see this is if we look at in the actual data plane. So let's do another capture. And let's say we're going to capture just ICMP. And then let's do a ping from 6 over to 7 again. Okay, so let's do the ping, and we'll say just the repeat count is 2 packets. Okay, as we look in the core of the network, we should see that the port number, source port is going to be random. Destination port is the well-known port, which is 4341. 43, I believe it's 4342 is the control plane. Both of them are, they're 1 port off of each other, which is, let me refresh that. Let's say clear IP LISP map cache. This is, yeah, 4342. So 4342 for the control plane, 4341 for the data plane, but the source port is going to be a random value. This is how it can hash between the multiple physical links in the core of the network. So let's again look at just ICMP. So router 6 does a ping. And what we're looking for here is what is the destination of the tunnel. Okay, so if we look at something that's in the core, destination was 10233. And if we look at some of the other ones, 10233, and basically based on the flow information, so it's going to be based on things like the source IP address, destination address, source port, destination port, it's going to choose between the 2 of them. So if we were to then vary the input to the hashing value, like the source IP address, we should see that it's going to choose the other link equally. Okay, one way we could check this in the data plane on the router is let's do some accounting on the packets as they come in. So let's look at on the diagram what physical links these are. From router 3's perspective, they're gig 1 23 and gig 1 313. So let's say that on router 3 we have two different ACLs. We're going to create access list 101, permit IP any log, and then access list 10. Well, actually, no, let's not say. Let's do this. Let's say access list 101 is going to permit UDP any equal to 4341, which I believe was the port number again. 4341. And then permit IP any. And then same thing, access list 102. Permit UDP any equal to 4341. Permit UDP or permit IP any. Okay, then we're going to apply these in on the interfaces. So IP access group 101 in on one of the ports, and then on the other port 102 in. Okay, the point of this is that when we look at the show access list, I want to see the counters between these two UDP flows. Okay, so let's now say on router 6, when we look at the physical interface there, that we're going to source the traffic from multiple addresses. Okay, and actually, let me do this the reverse direction. Let's say from 7. Okay, so from 7, we'll say we have the address 10.3.7.101/24 is secondary. 102, 3, and 4. Because if we're pinging between the same source and destination, it's not going to hash between the two of them. In a real design, this wouldn't be a problem because your inside addresses, your servers are going to have different IPs and they're going to have different port numbers. Like if it's a web server and you have multiple HTTP GETs coming in from it, those are going to count as separate flows and those would be distributed separately. Okay, so from 7, let's ping 6666. Source is 10.3.7.101. 102, 3, and 4. Okay, on router 3, then if we look at the show access list, we should see that, and actually we're going to need more packets than that. Let's say we were to do let's try a telnet. Okay, telnet 6666, source is the loopback. Versus the source being gig 1.37. I'm still only going one way. Okay, let's try it from the other direction. So on router 5, let's say show run section LISP, and I want to also advertise that connected link between the two of them. Okay, so let's say router LISP. The database mapping is going to be for 10.560/24. On the map server now, if we look at the show LISP site, we should see router 5 is advertising that prefix. And then from router 6, let's do a ping to 7777. Source is 6666 versus 10.566. Let's see, is that on the right interface? And we're advertising 10.3.13.3, which is the correct address. Okay, let's try the interface address. No, we're still not getting anything. Let me make sure 5 has both of the mappings. Let's look at the show IP LISP map cache. and that we need to be able to reach 10.3, 13.3, and 10.233, which we can reach both of them. Let me look at the capture. Maybe I'm matching on the wrong UDP port. Let's say, is the IP destination in there that is equal to 10.3, 13.3, which is 4341. Maybe I called the wrong port number in the ACL. Show run or show access list. 4341. For some reason, router 3 is not accounting the packets there. Gig 1.313. IP access group 102 in. That's kind of strange. But in the packet capture, we can see here that the destination, it changes between the two of them. So let's just look at ICMP. And if we go through and let's say specifically let's do this. Let's say IP.source is equal to 6666. And then as we go through these, we should see that this field here is going to periodically change depending on where the packet's coming from. So that one's 10.233, and then it's 10.3.13.3. So it's not going to be a one-to-one basis on a per packet basis because we're load balancing per flow. But if for real traffic patterns over a longer term average, you would see it kind of equal out to be on a one-to-one basis based on whatever the ratio is that you're defining. But what's kind of nice about this is that there's really no other attributes that you need to modify in terms of like BGP path selection. It's simply that the device that wants to receive the traffic in multiple interfaces, we just need to advertise those interfaces as the routing locators and then set the weighting to be whatever ratio that we want. So again, if one of the interfaces was like 10 gig and the other one was 1 gig, we would just say that the weighting is 10 to 1, and then it's automatically going to distribute the flows equally based on whatever the ratio is that we define. Now, the other more common case for this would be, though, that you have these interfaces that are split between multiple physical routers. So let's now say we have the case where there's not only one ingress and egress tunnel router, but there's multiples. So now we're going to have router 4 and router 5 that are servicing the same site. Okay, so on router 4, let's make sure that we have basic reachability within the infrastructure. So on router 4, let's make sure that we can first ping to the map server and resolver. We need to make sure that we can ping the other ingress, egress tunnel routers, which are router 3 and 10.3, 13.3. Okay, and also we need to make sure that router 6 is sending some of the traffic in that direction. So if we look at on router 5 in show run section EIGRP, we're using EIGRP internal routing, and then it's advertising a default route over to router 6. Okay, so router 4 is going to do the same thing. We're going to go to interface gig 146, advertise a default route to router 6, and then run EIGRP on all the links. Okay, from router 6's point of view now, if we look at the show IP route, we should have 2 ECMPs installed for the default. So router 6 is now going to hash some traffic to 4, some traffic over to router 5. Now, again, remember on the map server, map resolver, when we look at the show run section LISP, what this box does not know is what is the ingress egress tunnel router and what are the routing locators that they are registering. So basically, we can have both router 4 and router 5 register the same information, but we need to make sure that what they're registering is equal. Otherwise, there's going to be a problem with the database mappings on the map server. Basically, what this means is that on router 5, when we look at the show run section LISP, we're going to have to register the loopback, this interface to this routing locator, and the loopback, this interface to this routing locator, but both on router 4 and router 5. So you basically just create the config template on one, paste the exact same information on the other one, and then it should be registered in both directions. Okay, so specifically what this would look like is, let's go ahead and copy this out. We'll say that we have the mapping that goes to 5, but it also goes to 10, 10. Let's see, on router 4, let's say do show IP route connected. Okay, that's going to go to 10, 4, 11, 4. And then we're also going to advertise 10, 4, 6 in both directions. Okay, so the map server will need to be updated in order to accept this one as well. Okay, so this is we're gonna say that on router 4 and router 5. On the map server now, if we say under site router 5, there's a new EID prefix and endpoint identifier. They're advertising now 10.460/24. Okay, if we now look at the show LISP site detail, and if we look at specifically, and we could say the individual site, so if we say like site name is router 5. And if we look at the let's say, how could we sort through this a little bit better? Let's say pipe to include the EID or up would be this. Okay, so basically it's saying 6666 is reachable via, and also let's say based on the ETR, Egress Tunnel Router, or ETR. So it means that router 5 is advertising it has reachability to 6666 via router 5's link and 4's link. Then router 4 is saying I have reachability to 6 via 5 and 4's link. Okay, it also tells you whether this is your local link or whether this is somebody else. But the key here is that these entries need to match up with each other. Otherwise, the map server is going to have inconsistent information and you're not going to be able to forward correctly. Okay, if we now go to router 3, who is the box on the other end that's actually doing the resolutions, and if we look at the show IP LISP map cache, let's do a clear of that, clear IP LISP map cache star, and then let's say 7 is going to ping to 6666. Okay, router 3 should now see this entry located, and it says there's multiple locators that I can use to reach it. If we were to look at this again from our packet capture point of view, we would see that sometimes the traffic is going to go from or through router 4, sometimes the traffic is going to go through router 3. Where this one went from 4. Okay, then depending again how router 6 is hashing, because now it's doing an ECMP, then likewise we would see it at hash, should be normally on a one-to-one basis, but again depending on the flow information. But again, when you compare this to like BGP traffic engineering or IGP traffic engineering, it's very, very difficult to do this because you can only do the selection based on the destination information. You cannot do it based on a traffic ratio that would be analogous to your bandwidth. So you buy a 100 meg service from one ISP, 200 meg service from the other one. With BGP, you can only do equal cost multipathing, and then one link could be pegged, the other link is 50% utilized. But with LISP, you can natively solve this just by configuring that weighting under the routing locator as you're doing the advertisement. Okay, questions up to this point on this example with doing multiple XTRs on the same site. There's a question, could I just advertise the routing locator as the outside interface for 6666 and not the internal links? Normally, yes, you would do that. Because typically, you're not sourcing traffic from the infrastructure links themselves. You would just be advertising whatever your segments where your applications are. So if your web server is on the subnet 6666/32, you don't need to advertise these because no one is actually pinging the link itself. They're just sending traffic to whatever the end application is. And then again, the shortcut for this would be to do the config like I had done on router 3. which is to put the multiple routing locators in the locator set. And then the database mapping calls the set, so it's mapping it to both of these at the same time.